For standard deviation and how it measures the spread of the data. We had our original 5 kids sitting on the seesaw at 3, 4, 5, 6, and 7 feet. The mean was at 5 feet, and we were looking at kind of on average, how far are these points from that mean or balance point? Let's try a second example, this time using our calculator. So in the second example, we have the kids sitting at 3, 4, 5, 6, but little Johnny moves out to 17. So our picture looks very similar, except again, this point out at 17 shifted way over to the right. That caused our mean also to shift to the right. It moved from 5 to 7 to balance out that shift in our observation. So now, before we look at our calculator, let's think about what we expect. Do we expect the standard deviation to be smaller, larger, or about the same in this case? Hopefully you're thinking larger in this case because our points are further from the mean. The distance is 17 from 7, that's 10 away, whereas up here these distances were a lot smaller. So we expect the average distance of points to the mean to be a lot larger in this case. So let's find out how to do that on our calculator. So first we need to enter the data. We'll be doing this quite a bit. So you're going to go to Stat, and then just press enter right there on edit. We want to add some data. And you'll notice you get this Excel chart kind of looking thing where we can enter our data. So in list 1, let's put our observations in. I've got 3, 4, 5, 6, and 7 are where the kids are sitting. Then we can go back to Stat. This time we want to do some calculations on the data. So move over to the second option, Calc, and then choose the first option there, 1 var stats for one variable statistics. We have one data set we entered, and then just go down and calculate. You'll see all kinds of information here. Oh, I did the first data set, didn't I? 3, 4, 5, 6, and 7. You'll notice the mean here is 5, which is the mean we had for the first data set. And then you'll see some other things we're not going to be using, but you'll notice SX. That's the standard deviation, SX. And it's 1.5811, which is exactly what we got over here when we were doing that by hand. Now let's go back and edit our data entry and find the standard deviation for this data set. So back to Stat, press enter on edit so we can edit the data, and then scroll down that last data point. Instead of 7, let's make it 17 and press enter. Okay, so there's our new data set where we've just changed the last observation. Now we can go back through those steps, go back to Stat. Now we want to do a calculation, specifically one variable statistics. And just by default, it's going to look at what's in list 1. That's where we've put our data. And you'll notice X bar, the mean is 7, which is what we calculated by hand earlier and what we drew on our chart here. And then SX is a standard deviation, so 5.7009 if you round it. So this is our new standard deviation. Let me write that down over here. S equals 5.7009 feet. Okay, and if you want to make a few notes to yourself about how we did that on the calculator, go for it. It's under Stat and then Edit to enter your data. And then we went to Stat and Calc and 1 var stats to get some information. We got X bar, and then SX gave us the mean and the standard deviation of our data set. And indeed, notice here, the standard deviation 5.7 is huge compared to what we found earlier, 1.58. So changing one observation definitely changed the standard deviation quite a lot. So that comes to our next question: is the standard deviation resistant to outliers? And that's a big no. When we change one data point to make it an outlier, the standard deviation also changed drastically. Finally, let's take a look at values that can or cannot be a standard deviation. 1.2, sure, I should hope that could be a standard deviation. That's pretty close to what we got earlier, the 1.5. 1 times 10 to the negative fifth, that can be a standard deviation, no problem. It's just written in scientific notation. That 10 to the negative fifth means move the decimal left 5 spots. So that's like 0.00001. So it's just a small variability. 100, sure, large variability. Negative 2.1, definitely not. Standard deviation can never be negative. We're squaring values and taking the square root, so standard deviation cannot be negative. That's the big takeaway here. All right, keep your calculators out for the next video. We've seen some improvement with this measure of spread, average distance of points to the mean, but we did see that it's not resistant to outliers. So let's keep working here.